Okay, and we've started the recording. So, welcome everyone. Good to see you. So today we have our user meeting number 6. So here's what we've covered in our previous meetings. So we had an overview of the platform. We covered some basics for custom development and JavaScript API. We did have an in-depth session on data ingestion. Then the next 2 sessions, we've been covering data visualization quite extensively. But still, we did not have enough time to cover the JavaScript API and some other parts related to data visualizations. So today we are going to finish what we have not finished last time, and we will also touch base on predictive modeling. So in more details, today we will review our JavaScript API and the way viewers could be built externally. As an example of that, our colleagues from Arcadia, Alexander and Nikolai, will demo a viewer that they have built completely externally from us that resides probably on their private repository, I'm not sure. And then we'll introduce the concepts of predictive modeling and different ways users can build, apply, and compare predictive models without leaving the platform. So if there are no questions regarding the agenda, I'll give the microphone to Alexander Paramonov, who will walk us through the JavaScript API for viewers and perhaps some more general applications of our API.
Okay, thank you, Andrew. Can you hear me?
Yes.
And Andrew, will you please allow me to share my screen?
Right. Is that you, Alexander?
I can see it.
Zoom hides its own controls. So we have.
Yeah, my name is Alexander.
All right. Great.
Okay. Yeah, now I see it.
Yeah, you are the host now, so you should be able to present.
Yes, I'm able. Okay, let's start. Okay, can you see my screen?
Yes.
Yeah, first of all, let me remind you what the packages are. The package for DataGrok is developing unit, the unit that contains can contain JavaScript code, Python code, R code, or basically everything, every entity that can extend DataGrok functionality. Each project has a version. So I don't know if you can see my mouse. I'm showing you ChemSpace v02. That actually shows that this package ChemSpace has only one version and it's active. As I said earlier, each package can contain pretty much everything, but today we will take a look on the JavaScript functions. I can say something more about versions, that package version can be active or can be disabled, and they actually can be open to users, or users can see disabled versions. So let's take a look on the package. I chose leaflet package. This is a package that contains a viewer leaflet. Let me show you how it looks. This is a leaflet viewer. It's based on the leaflet package and shows such a pretty heat map. To make this viewer available to Datagrok, we basically need to make a function. As you already know, everything in Datagrok, everything is in package is a function. So this function returns a viewer. And if we look to leaflet viewer class, it extends dg.js viewer, and it basically has a few methods to provide all the functionality and to fit in Datagrok seamlessly. So to develop a custom viewer, we need basically to implement on table attached method. It's a method that called when a viewer attached to a table. We must implement on property change it. Here we just render view on size change it and detach. This is pretty much everything to make viewer work seamlessly inside the Datagrok. When user press button that calls viewer, Datagrok automatically loads package code and executes this function to show a viewer to a user. Please feel free to interrupt me at any time if you have questions. Okay, I won't show you in details because this is JavaScript specific, and everyone who interested can actually see this code in our public repository, and this public repository is actually my next topic. To organize packages, Datagrok supports repositories. So not only packages can live not only as a single entity, but they can live inside repository. Here is a repository that links our public GitHub, and I can publish all the packages from this repository with one click. Let's take a look at this. I have Zoom panel that prevents me pressing. Okay, here they are, and here where you can take a look on this leaflet package code. Here it is. Okay, all the packages are organized inside in repositories, and organization can also add here on organization repository by using this button, and publish packages from our public repository and organization repository simultaneously. All packages inherit repository permissions, and that's how packages can be organized. Also, we have a method to debug package on our server. So if you publish the package from Datagrok utility from the development studio, there will be a new version added and marked as debug version, and no one actually would see it. Only the person who posted it. So that's pretty much all how a new viewer can be added to Datagrok. Again, you just need to make a function and make a viewer class that extends the GJS viewer with necessary methods. What about functions? What can package also contain? Package can contain pretty much everything. For example, it can contain scripts on Python or R. Let's take a look at R scripts package. Here are many R scripts, and this is a package with R scripts example. If we take a look, yeah, here they are. All scripts are here. And as I mentioned before, one thing I want to show is that everything in Datagrok is a function. What does it mean? Let's take a look at the script. Here is a simple script that written on R. It has no input parameters. It only has 2 output parameters. And it returns two very simple tables, just in case example demonstration. Let's execute them. Okay, here are 2 tables. And what if I want to execute this script from JavaScript code? Let me show you 2 examples. This is first of them. This is actually a very simple code to execute this script. What does it mean? This is a Grok functions call to our API, and this is a script name. As you can see, when I executed manually, this script name was printed to Datagrok console. You can copy and paste it from here and execute it. Of course, you can pass the parameters. Here we can pass a hash map with the parameters. There are actually a lot of examples of that, but I decided not to make it too complicated. And then after asynchronous call, this script returns a data frame, one of the data frame, because JavaScript only supports 1 return parameter. The first data frame will be returned and added as a table view. Let's give it a shot. Okay, that's it. The question, what if we want to get both data frames from here, from the script? There is actually a little bit more complicated API. Let's take a look on the second example. Here, please notice the difference. I call not the Grok functions call, but Grok functions eval. What does it mean? It means that after that call, I get a script object, not the result, but the script itself as an object. Then I will get this get in as variable and get it as a script. Script is a function, as almost everything is Datagrok, and I can call it manually and get the output parameters. So what do I need to do that? I need to call a prepare method that would return a function call object and then make a call. Why is this so complicated? That's because I can really customize here everything in the call. I can pass the parameters, I can handle the progress, I can handle logs and messages and everything else. And I can do pretty much everything with this fun call object. But now I just call it. And then after a synchronous call, I can call get param value method and pass it parameter name as a parameter and get these 2 data frames as output parameters. Yeah, as you can notice, here is 2 data frames in output. That is basically all that I wanted to show. I can emphasize and repeat that everything in Datagrok is a function, and everything can be actually stored inside the package and distributed as a package. Questions?
Yeah, thank you, Alexander, for that overview. Yeah, we did touch base on some aspects of our JavaScript API earlier, but yeah, that was a good overview. So now let's take a look at the example of a viewer that was implemented actually not by us, not by Datagrok, but by our colleagues from Arcadia. So Alexander Shevnin, yeah, please take the stage. Alexander, can you make him the presenter, please, as well?
Yes, just a moment.
Thank you.
Done.
Yep. Let me see if I can do it. Yeah. Let me know if you see my screen and can hear me.
Yeah, you can see it and I can hear.
Okay. Yeah, good. Okay, so just briefly introduce myself. So my name is Alex Shevnin. I work in Arcadia, and well, we've been working with people in J&J for a while, and then Covens. So that's basically how we acquainted with Andrew. And the team and Alexander as well. So we decided to in Arcadia we just decided to go and start with a couple of plugins to see if we can make anything good based on the platform. And as a simple example, we decided to start with Sunburst Viewer, as it's well, it should be simple enough, and it will allow us to actually learn how platform works, how to write all the plugins, all packages, and so on. Also, I didn't really want to write things in a JavaScript, so I let myself to play with TypeScript a little bit. In the scope of that Datagrok, and thanks to guys, so we've even merged a couple of pull requests that adds TypeScript definition support in their API package, so it's possible to write things in TypeScript right now. That's actually what we did. So yeah, and as Alexander already shown us, so it's basically follows the same pattern. We created JS viewer, but the only difference is that it's written in TypeScript. And let's just get to actual demo. So I do have a very simple data set here, which shows different sales and orders by different people in different regions. So if I wanted to go and, for example, figure out which of my people work best and sell the most stuff, I could use a Sunburst viewer. So it's a hierarchical viewer, and it actually allows you to go and drill down to a very item and see a whole hierarchy, a whole path that leads to it. So it's basically a whole table represented in this Sunburst chart. So Andrews sells a lot of pencils, so I can even go and filter them and highlight them in the data table. So we add a little bit of interaction here. but still, there are some things that we also need to support in the future. So this viewer is well, it's a work in progress. It's a way that we learn how the data grok works, how we can integrate with it deeper. For example, our next step would be adding some kind of aggregation function that would allow us to change the way these segments are calculated. So, for example, if I wanted to organize them not by a number of rows in a table, I would add some kind of a selector that, well, that would allow me to use like a aggregation by well, sum of units or a total to see how much money I make and so on. This is basically what I wanted to show. This package currently is available in our own repo. So this is a URL. But I think in the future we will create a pull request into main Datagrok repository. So we just need to polish some things up and add this well, configuration and other things. Fix some bugs if any. I think that's it. If there are any questions, feel free.
Thanks for the presentation, Alexander. So a question to everyone. Are there any viewers that you think are missing from the platform or would benefit it? And I know probably guys from Novartis have a couple of suggestions, might have a couple of suggestions. Or if there is any other piece of functionality that could be implemented as an extension, yeah, please do mention it either right here or on our community forum. So we would like to know what's in demand. All right, let's go to our next topic, which would be predictive modeling using our platform. Can the current host please make me a presenter?
Yeah, how do I do that?
You probably need
or?
to right click on my name and select
Yeah.
the host. We probably need to figure out a more efficient way for passing the ball.
Yeah, I just did.
Thank you.
That's when I felt power.
Okay, so let's talk about some of our functionality built around predictive modeling. So we'll overview different predictive modeling engines available in our platform out of the box, and they we have backends that work either directly on features that could be categorical or numerical, or we also have a way of building very custom predictive engines. And as an example of that, we've built an engine around a library called Chemprop that predicts some chemical biological activities of the molecule based on the structure of a molecule. So it's not a traditional model. And if we have time in the end, we'll also take a look at the JavaScript API. All right, so back to the platform. And let's open some data file, because it usually all starts with the data. So that's a tiny data set that contains different characteristics, different attributes of cars. If we open the models pane, we'll see all the predictive models that are applicable to this particular data set. So currently we have 3 models that the platform knows could be applied, could be used to predict something out of this data that we are looking at. Of course, probably the first question would be how do we determine whether we could infer something from a data set or not. So we use a set of heuristics for that. And it all boils down to mapping of the source columns that exist in the current data set with the features that the predictive model takes. So for instance, if we click on any predictive models available to us, we'll see exactly what the inputs are. In this case, it's wheelbase, length, width, and heights, and what we are trying to predict, and the method. So in this particular case, this model is flagged as applicable to this data set because there is a strict match between the types and names of these 4 columns. Types are not, they should not be an exact match. So for instance, if it's a numerical type, it does not matter whether it's an integer, big integer, or float. But it should matter whether it's numerical or categorical or some other type. Also, we match on semantic types, and this is the concept that we have covered in length during, I think, our second or third demos. So essentially, a platform automatically tries to determine the meaning of the data type and not just its name of end data type. So we take that into account as well. What we are also planning to support in the near future is specifying the type, the special type that would be used for that model, specifically for the purposes of mapping the data set to the model. And what we also plan to support is units, so that we will do the automatic conversion in case if units do not match. Some other ideas also include automatic conversion of representations. For instance, a country name could be represented as a full name or as an abbreviated name, and similar things applies to other data types such as chemical structures. So yeah, a lot of plans, and we already have a version that is pretty usable, but it will be even smarter in the future. So now that we have the model and we can see all its attributes, we can also apply it. So for instance, we can predict the price. And by the way, we do have price already in this data set, but we can try to predict this price by a set of attributes mentioned here. In order to do that, I simply clicked on this green arrow, and here is the outcome. It gets added to the dataset as the rightmost column. What's really convenient is that we can immediately go and see how well we predicted. So that would be our prediction, and this is the real price. Well, that's a little bit embarrassing. That's a straight line. That means we either overfitted really badly, or there was a predictor that was price in the inputs. But it did what it was supposed to do. Let's try to use some other model. Okay, yeah, now we get different predictions. If we press R on a scatter plot, we see that, yeah, and we can see it visually that the fit is not really good in this particular case. What else can we do with model? Possible to go and check all models available in the platform. The models are what we call entities in the platform, and this means that they are subject to all requirements of the platform. So, for instance, by default, they are only visible to the author of the predictive model, and they only become visible to others when people share stuff. Also, it's easy to share them, to search them. So, for instance, if we are interested in models that predict the price, we can simply type price, and here are two different models. In addition to browsing them, we can also select two or more of them, and then a command compare will appear on the property panel. So this will compare these two models, so we can see its numerical characteristics of how well the fit is. It also depends on the model, the number of attributes that we show here. So for some of them, we would see things like ROC curves and other performance characteristics.
Andrew, by the way, first of all, can you hear me? Because I'm using a different headset now.
Yes.
Yeah, that's great. When you use the term model, what exactly do you mean? Do you mean an instance of a trained model, or you use that term in the sense that you have a package that implements some kind of model that you can train and then cross-validate and then use for predictions? Because you use that word model. Is it something that can be applied to do the predictions right away, or it's a method itself?
Yeah, so it's a trained model. It's an instance of a model. Yeah. So we have predictive model engines. So these are different types of algorithms, which could be further parameterized. And I think I'll get to it right away. So imagine if we wanted to train a model and not just predict it. So yeah, we would click on this train button, and here we see different options. So that's what our terminology is. So the model engine is well, essentially a set of algorithms that are pretty much aligned with some specific technology. So it's just the way we implement it. So you can see we have three different model engines. So the first one is H2O. This is an open source predictive model engine, which is Java based. Then we have Carrot, which is R based. And we have Chemprop, which is a Python library that works on molecules. Now, for each model introduces a set of different methods or algorithms for training. And when we switch it, we can see it that in the bottom of the bottom part gets changed. So, for instance, H2O introduces these 8 algorithms or methods for building predictive models. So things like AutoML, deep learning, distributed random forest, and so on. Each method can have has different parameters. So these are more important parameters and also less important parameters. So it's possible to go and adjust either of them. Of course, some methods would do it for you automatically. So for instance, if we do AutoML, well, this method, this algorithm is supposed to select the best applicable method and tune the hyperparameters. But in general, the hierarchy is the following. It's the engine, then the method, and each method has a number of parameters that are specific for the method. Did I answer the question or other questions regarding that?
Yeah, now it's pretty clear.
Mm-hmm. Okay, yeah, let's predict something based on our data set. Again, let's try to predict price based on some 3 numerical attributes, and let's try to use AutoML. And there is no need to go to any other environments. We can build these more or less simple models, standard models, right inside of the platform.
So this is running right in your computer, isn't it? Not on the server?
It runs on the server currently.
Server, okay.
Yes, all the predictive models, they get trained on a server, and they also get applied on a server as well. It is possible to install that modeling engine on local computers as well, but yeah, that's technical details probably outside this particular session. Yeah, so within the organization, the way it works technically is that we have typically one application server within each organization and one or more compute servers. And these compute servers have the ability to spawn dynamically based on the load. And predictive models, they get trained on the compute servers.
By the way, what happens if, for example, you have a model that takes a while to train, and you click the button, train button, something like this, with hyperparameter optimization and all those bells and whistles, and then you go away and simply like disconnect from the network for a while. Does it actually finish it, or how do you find it later? You know.
Yes, it will finish. The way you can find it later is either by going to functions and models, and here you can filter it by well, by your training time or by any other means. Well, yeah, that would be the easiest way to find your model.
So in general, Datagrok, if you launch an operation that takes a while and then you simply quit the session, does it in general keep running?
So there are 2 types of computations that we have in Datagrok. So by default, it will keep running, and the results will be on a server for the client next time they are requested. Also, for most of the computations, and computations could be anything, database queries, function calls, predictive model calls. So for most of the computations, we also have an ad hoc parameter, which essentially specifies that this is only needed for this current session. So if say no one asks for it, the results and everything gets deleted. Probably Alexander Paramonov, did I describe it well, or?
Yeah, you described it well. Most of long-running actions are wrapped inside function calls that uses database to store results and storage to store tables. And if you close browser tab and open it again, such functions will still be running, and even you can even attach to this running process to get to the same state before browser tab was closed.
Mm-hmm. So what if you, for example, launch something like model training or something, some long operation, hence resource consuming operation, or a huge database query, and then you realize that you made a mistake and need to cancel it just not to waste the resources? Is there any way to do that?
Yeah, there is actually a mechanism to cancel such functions, but not every task can be canceled. For example, at most cases, database queries can't be canceled, but Datagrok can cancel it if it's available by external resources.
I didn't get it.
For example, you can cancel a database query, but database server will perform it anyway.
Okay. Mm-hmm.
But the things we can cancel, Datagrok, of course, can cancel. Yeah.
So model training, you launch this H2O based with hyperparameter optimization, and then you realize you need to tweak the properties a little bit and relaunch it. Is there any way to do that?
I'm not sure. I think it's not implemented yet, but it's possible. Yes.
Mm-hmm.
Yeah, let's see if it is indeed here. Honestly, I don't remember. Well, you can certainly close it, but it probably does not cancel it.
Yeah, probably it continues running on the H2O server. I don't think there is now an ability to cancel it on H2O server, but if H2O server allows that, we can do it, of course.
Mm-hmm.
So we have a mechanism inside Datagrok to fully control our running process. So we can cancel, we can attach to this process from other session, and so on. But everything depends on external services.
So once you click on the train button, it runs, and the train button gets deactivated, right? So you cannot click on it twice.
It's just a simple debounce mechanism.
Mm-hmm.
Just not to click it 2 times.
It's actually still active.
Active, yeah, that's strange. It should be deactivated, of course.
Mm-hmm. Yeah, and by the way, if you've used the platform, you might have noticed this icon. It's pretty convenient. It exists on
Mm-hmm.
most of the dialogues. Just lists your parameters that you've used previously, if again they are applicable to the current data set. So you see, we only see stuff related to the cars data set, not to the other. All right, so let's see if something different this time. So let's open a data set with chemical structures, and let's try to first train a model. using the Chemprop engine. So we will use smiles, a molecule, well, as a feature for prediction, and we will, well, that's pretty good. We will try to predict the solubility. And yeah, Dima, actually, I'm sure is quite familiar with this model since I heard you're using the same one in J&J. So we do have
not in its raw form though. We've significantly changed the inner workings.
well, yeah,
because in its raw form it's not very useful because of some intrinsic features of chemical predictions. You know, there's some things that I will not go into right now, but in most cases you need to use it with caution, to put it mildly.
Right. Well, let's try to predict this solubility. I'm actually not sure how long it will take. That does not look like a big data set, 1,000 columns. So, Alexey Sahnyuk, do you have an idea how long it will take? Oh, okay. It's actually just been built. Let's click on the model to inspect it. Oh, well, everything is everything looks proper. Yeah, by the way, as I mentioned, it is since models are entities in our platform. Yeah, we can.
Hold on, I see that performance dropped down. Is it the result of cross-validation, or what are these numbers?
I believe it should be the result of the cross-validation.
Because it's not obvious. I mean, you can't tell.
If we, yeah, you are right. We should provide more hints regarding what exactly we are looking at.
So this is the result of a training session, of that training session you've just done, right? Or something else.
Yeah, that was the result of the training session. And let's try to run it. I believe it should also work. Okay, we got some outcome. No. Oh, actually, here we got a much nicer view of the solubility. So indeed, it predicted the solubility pretty well. And yeah, Dima, you probably know it by heart. It was a pretty easy endeavor, right, compared to using.
Well, there.
I
assume those are solubilities in water, and most of those molecules are practically the solubilities are like 10 to minus some. Actually, they're practically like gasoline, you know. They're all saturated. No, actually, there's some other types.
Yeah.
No, I thought they were all like that. Yeah.
Yeah, I agree. I was also very suspicious just looking at the beginning of the data set. Yeah, they're all different.
Yeah, that looks a little bit better, more interesting.
And yeah, it's also possible to extend the platform with different model engines. Actually, we are working on that. Sorry, it's not possible yet. But we are planning on introducing the functionality where you would be able to introduce a different, completely new model engine via an extension to the platform. So things like Chemprop, people will be able to add externally without involving us. And this is pretty convenient. So yeah, if you notice, it's all pretty visual. You have a complete lineage of where the data came from, which transformations it underwent, who trained it, why, on which training set, what the performance is. And yeah, the results are immediately useful. So not only you can train the actual model and deploy in the sense that you will be able to use it programmatically, but you can also use it as an end user right from the platform.
So in this particular plot, the outcome and the actual solubility are from the same set that's used for training, right?
Yes, yeah, I just use it on the same set.
But you clicked on the train button, so where's that train model now? How do you find it, and how do you apply it to a different data set?
Well, you would simply open a different data set. Well, let's open a similar one. And then it would get suggested to you. Actually, that was the model that I built previously. I ran the other one. Yeah, so that's one way to do it. Just open something with, in this case, I think it was looking for either a column named smiles or a column with a semantic type molecule. And in this case, it's a perfect match. So it will get suggested to you automatically. And the other way to do it is, again, to go to functions, models. We actually should introduce additional filters by model engine and so on. And you can search for stuff like smiles or something like that.
So it actually tries to figure out whether a particular trained model is applicable to the current table by looking at the columns on their semantic types, right?
Right. Yes.
Well, one thing I can sort of one problem I can sort of see with that is that if somebody builds a whole bunch of models, and this is going to grow to a pretty big list, because say there can be tons of data sets containing chemical structures, and you can have a list that consists mostly of totally irrelevant models, because it'll think that everything that was trained based on the chemical structure is applicable to any other data set that also contains chemical structure, which is usually not the case in real world.
Yeah, that's a valid concern, and yeah, something that we are also planning to extend the platform. Essentially, a way to specify more precisely what it is applicable for.
Yeah, I do not know. Maybe it would make sense to add some kind of checkbox or some kind of setting to the properties of the models when you specify parameters for training, whether that model is like general applicability model or a narrow applicability. And if it's general, then show automatically like this. If it's narrow, somebody knows that that model is so specific that it doesn't make sense to apply to random data sets based upon just the columns and their semantic types. And then the user would just click that button and the model will be only visible in the list and could be applied explicitly, as opposed to being suggested. I think it would make sense to do that. Otherwise, people would be applying models that are totally irrelevant.
I agree with that. Actually, we've done already some work on a somewhat similar subject. So when we train a model, we record some basic statistics for the features. So things like, of course, minimum, maximum, and some distribution, and so forth. So if you try to apply it on a data set that matches by just having the columns names and types, but the features lie outside of the range that was used for prediction, you'll get a warning. And yeah, it's somewhat similar to what you were suggesting in a way that we are not going to show everything, but we will be narrowing it down.
Yeah, I think it would make sense to actually have that explicit kind of flag or whatever, because I see, especially with non-trivial features like chemical structures, you can't really tell, I mean, easily, because they're not numbers. You can't tell whether that table had chemical structures of a certain type or whatever. You can imagine it's kind of difficult. Say if you train Chemprop type models on chemical structures or biological sequences or some non-trivial input parameters and automatic mechanisms for determining the applicability domains will fail. So it would just make sense to have that setting, and a user explicitly would say, okay, I want this model to be like visible and suggested, and I don't want this model to be suggested because I know that it's not going to work in most cases, you know.
Yeah, that makes sense. Actually, yeah, Dima, if you have a good use case for using that functionality within Johnson, yeah, let's work on that. We are totally open to introducing features.
I mean, I think it's very simple, because you just add that flag and prevent that model from being suggested, you know, in those lists. I think it'll be a kind of useful feature.
Yep. Yeah, I agree. We will also have a way to specify a function, which could be, again, any function, Python or JavaScript, that would explicitly check whether a data set is applicable for the model or not. So that would also be an option. And another thing I did not mention is that we are considering implementing a mechanism that would automatically translate not only between units for numbers, but also between different representations. So for instance, a molecule could be represented as a smile string or an SD file or some identification of that molecule in an internal registration system. So, and the way it would be implemented is by functions that would be annotated appropriately. And then the platform would take everything into account and would automatically translate between representations and suggest models that were built on a slightly different representation.
And I have one extra question about models. Is it possible to use trained models, I mean Datagrok trained models, outside of Datagrok through some kind of API?
So it's not possible to, I mean, yes, but we would need to make some work on our side. And this is something that we are doing already with integration with Domino and Seldon platform. That's exactly when people would train models outside of the platform, but the platform would hook to them. Yeah.
Well, I mean exactly the opposite. I mean, we have trained models, a list of trained models. Is there any way to say I have a Jupyter notebook or even 3DX or whatever, any client, external client, to say use that model through some kind of RESTful web-based API or whatever API, essentially just without using Datagrok, visual Datagrok, you know, simply connect to the endpoint and send the data set and get predictions?
It should certainly be possible, but not currently. It was on our radar, but yeah, I have to admit it's not possible at the moment.
Yeah, it'll be a pretty useful feature. I can see that because it's very convenient to train models from Datagrok, but quite often they have to be used outside. Say somebody has a pipeline pilot protocol or whatever, and that thing just connects to the train model and predicts things, you know, in some kind of
Yeah.
scheduled job.
Yeah, on the other hand, also I would like to add that in some cases you actually want to be able to package it out and be able to, you basically operationalize it in a different environment. If it's something that is going to be used, you know, let's say for production. So it should be possible to basically somehow take the model, package it out, be able to execute it in some other environment, let's say some production environment that is only used to basically to pass data in, probably with larger data sets, or need some kind of you know, some kind of Kubernetes cluster or something like that, and be able to run it. So that to me will be another use case for reusing the model.
Yeah, this could be done as well, although this would require some support from each model engine.
Yeah, that can be somewhat difficult because say look at Chemprop models. It requires a very specific Python environment.
Right.
It's not a like off the shelf, you know, type model.
Mm-hmm. Yeah, it's easy to do for some engines such as H2O and Carrot, but even with Carrot, you would still take some dependency on the version of the Carrot package and R as well. So yeah, we can discuss some particular implementations, but yeah, generally it depends on the predictive engine.
Yeah, but for the API, I would imagine a nice kind of interface would be like you're looking at your list of models right now. You just sort of click on that model on the right side in the properties. You would get the URL essentially with the API, and you simply copy paste that thing, and it can be pretty complex though, because to be able to use it easily, you would also have to sort of make sure you expose a description of that API, you know, for example, a Swagger file, so that the client would know how to use it actually, because otherwise you just do not know what the parameters are.
Yeah, it's a big topic. It's also related to exposing the rest of our functionality as a REST API. Yeah, the same thing is applicable for data connections, data queries, functions, and even file systems, and so on. Because that's what the platform is doing, right? Once you deployed it in your organization, it connects to a lot of different things and can calculate a lot of different things, which could also be automated. So yeah, that's the direction we are going to. So it's not available at the moment, but obviously it's high on our priority list.
Yeah, that looks really cool actually. Yeah. So I need to just try out. I think I'll try to run some of those Chemprop based models and see how they actually predict. I'm just curious because is it the newest version of Chemprop or some kind of older one? I mean, the MIT package itself.
Alexander, do you remember which version did we use? I think Vasily used switched to the latest one a month ago or so, but I'm not sure. Yeah, sorry, Dima, can't answer you that at the moment.
Yeah, that's fine,
Yeah,
but it looks pretty cool.
Yeah, thank you. Yeah, we thought in general, building models and not only building, but assessing and deploying them to the end users should really be easier than it's currently done in other environments. So our goal is to make it as easy as possible. So yeah, please keep your suggestions coming.
Yeah, and regarding the RESTful API, you can sort of undertake the same approach that Seldon has. They have containers for models and they expose those endpoints, so it's still in development and Seldon that's not fully stable, but at least they are moving towards like more structured API. So they just have endpoints that expose APIs that have certain types, and you can automatically download the Open API spec file and generate client if you need to.
Mm-hmm.
Maybe just like write it down as a useful feature, maybe for future development. It can be somewhat difficult to implement, but
yeah, you also did mention containerization. That's something that was on our mind. Yeah, currently by default we follow the other approach, so everything, so we don't create extra containers for running computations or modeling, but yeah, we might have at some point, yeah, for the purposes of reproducibility, but yeah, that's another discussion.
and usually, most of the development is on handling exceptional situations. Say you launch Chemprop training and the thing throws an exception somewhere. What kind of feedback would the user get if training fails, for example?
We do try to collect everything that's possible, so I assume it should be yeah, probably the stack trace inside our platform. That's just in case if something crashed on the Datagog side. And regarding the model, I assume by default it should be the console output if it has one, right?
Mm-hmm.
I don't think we do it at the moment. Alexander, correct me if I'm wrong.
I think we collect console output for training, but I'm not 100% sure.
Mm-hmm.
Yeah, I know a few smile strings that would crash it, so I'll give it a try.
Oh, don't. I'm kidding.
Yeah, I remember once I took the entire ChemSpider offline because I found a couple of smart spider, and so when you do a substructure search using ChemSpider, which is which is a kind of world-known engine, I know a couple of smart strings that predictably crash the entire service if you try them. I'm curious whether they fixed it or not yet.
Yeah, maybe we should restrict Dimo's privileges in our platform. All right. Are there any other questions? That's pretty much all we wanted to show today. So I don't think there will be any more new material.
The traditional question, have you fixed the table join?
So it's on our development environment. Deployed yet. Yeah, I figured you would ask that question, Dima. So I did some work. All right. Last call for questions.
Thank you so much. Have a good one.
Okay, yeah, thank you so much
Thank you.
for joining. Yeah, I will hope to see you in 2 weeks. And yeah, let's have 15 minutes back.
Goodbye.